they'd actually done, the others could share and see. And so I think that when you've got feedback then to them personally and generic feedback to the class, the pedagogy itself changes too. Now I'm going to move on to another science example, which is that of global warming. But here we go. Here we've got a screen where you've got on the left-hand side 7 variables that can be changed to affect the global warming model. And if you start to use the slider on the left-hand side to change those variables, then you will see a change in the temperature, the graph, on the right-hand side. And this was a system that we were using a few years ago, the students were using on their own. And we wanted to do some collaborative work and some collaborative assessment. So we built SimLink, where we could link the students together by text, and you can see underneath you've got where it says room. Chris is talking to Simon, saying, why don't you see what happens to the temperature when you increase the amount of CO2 in the atmosphere? And here Chris and Simon are working together. So what we did here, which was, we've got problems with bandwidth as well, right out in the countryside. And so what we did here is we had a screen where students, if you look on the left-hand side, there's a map of the UK. And the green dots show where the students are on a course and whether they're active, whether they're online. And then they can link to one another, do the tasks together. But what's more important here is there isn't full screen sharing. What we're doing is just exploring and exchanging mouse clicks. So that, you know, has got over the problems of bandwidth and it's worked very well. Now, why do we think, you know, this is important? Why do we choose this task? And that's because 2 heads are better than 1 when you've got to do a task where you need 2 heads. Don't give, you know, students things, tasks to collaborate on where you don't, where they're not complex enough. And so this is why we chose this sort of activity. Now, the other area we've been looking at with feedback is to scaffold high stakes assessment. Now, this is quite problematic to get through the university, but this is only a 10-point course. It's maths for science, because at the Open University you don't need any formal qualifications to join our courses, and you don't need to in the first level science course. But if you want to move on, we know that you've got to have a level of competency in mathematics. And so if you don't have a mathematics qualification, then you need to do this course before you move on. It's only 10 points. It's called Maths for Science, and it hasn't got a tutor. It's competency-led. And we said that we would give students 3 goes at answering the question in the final examination and in their practice scenarios. And we would give them some feedback. So therefore, you'd only get maximum marks if you answered the first time correctly. And marks would be deducted for how much help you received. This was quite difficult to get through our exam boards, but we said there's no point to cheat here. It's a web home exam. It's worked immensely well. And we're now bringing in, we're looking at invigilation technologies for the home with cameras, etc., especially for students now who are in the armed forces. They need to take their exams abroad or are working abroad. And so we're thinking about doing that as well. But here we've got a high stakes exam with some feedback during the examination. And of course, mobile technologies are becoming important with for feedback and using all sorts of different tasks. Steve Draper, who's written his paper up in the special issue I did in BJEC, he's with electronic voting systems, how there are clever ways of using these and interacting with the students, and using the mobile phone for MCQs and students to work together. This is Valdez's work in South America, where the children in the classroom have got their mobile phones and are using multiple choice questions. But if we're going to give automated feedback, then we've got to have some form of automating the marking of whatever answer has gone into the system. And free text entry is something that's on my mind at the moment, and I've been working with, and it's really going to push us and move us forward if we can get to terms to this. Now, we've got a background in this, and a lot of people are working in this area. I mean, ETS are really important company in this domain, and Steve Pullman, who I'm starting to work with at the moment, who's a natural language specialist, many of his doctoral students actually go to work for ETS. And we've used Mitchell's system in the university with Sally Jordan, who's used that to give some free text entry to science questions, but they are very limited at the moment. Now, what I want to do now is I want to move to the second half of my presentation, which should pop up now. And I want to tell you about open comment. Open comment is a system Here we go. Open comment is a system that's got free text entry, it's got automatic feedback and guidance, and it's based in the history domain, and it's used by the arts faculty. Although I've got a science background, the university asked me to try and move into and work with the arts faculty, because they said, well, multiple choice questions aren't really what we want. Can you make us something better, something more suited, bespoke to ourselves? So obviously, we're not there yet. We can't just use any old type of questions. So what I did was I persuaded a historian to work with me and to think about, did he have areas, domains in his subject area where I could actually do something if we had causality, if I could work with causality. So we chose 3 different types of questions. Analysis of statistics, because history uses, tables, births, deaths, changes in population with employment, such as with the Industrial Revolution, when people were coming to work on the land into the cities, and comprehension of a set text. I'll show you some examples of that, and then identifying similarities and differences for a given event. Open Comment's Java-based feedback shell, and we built a new Moodle question type, and it's got an editing tool for tutors to put in new types of questions. Now the screen actually looks like this, and here's a typical question on the course, what were the causes of the First World War? And here I've actually put in, I've got no idea. And if we move to the feedback on the first screen, and you can see that the system comes back with, maybe you're a bit confused by the question, it might be helpful to remember you're not being asked about the causes directly, but why the causes have been so extensively studied. And so the system goes on to help you when you put the second answer in. And here we've got some feedback and by the student, then we've got feedback from the system. which picks up on the answer, the main points that were in the answer. And if you look, you can see it says, well done on this submission. There is a praise there given to the student. I'm going to come back to talk about that in a moment. Because underneath this model, underneath this feedback, there are stages, a model of the what the system should do, what it's going to look at in the student's answer, and the sort of feedback it's going to give. So the first phase is, and this is something I designed, and it looks like I could have done on a Sunday afternoon on the back of a brown paper envelope, which took a very long time of analysing tutors' feedback to students, is the detection of errors. So first of all, the system looks for errors, glaring errors, incorrect inferences is dealt with later, but it'd be things like incorrect dates and facts. But what we've taken note of is Dweck's work. Dweck in the United States, a psychologist, has done a number of big studies with school children, where she found that children who are very clever and are praised for being clever never put themselves in a position where they are going not to be seen as top or very clever. And that often with learning, it's a lot of sweat and tears rather than just ability. And they set up experiments where those who were praised for effort actually went on to actually undertake a second task when they were offered it, and those children who were praised for their ability did not put themselves in a position to take a second test. So in all the feedback that we're giving, we're trying to recognize effort and encouraging students to have a go. So for example, here you can see you've done well to start answering this question, but perhaps you misunderstood it. Instead of thinking about X, why don't you consider Y? So we've been very influenced by Dweck's work. So the first stage is to look at find out if there are any errors. The second stage is to look at omissions. So is there something missing? And then again to look to see if there's a second omission. So the idea is to detect errors, then look for omissions. And then in the final stage of the analysis, we are actually looking at the clarification of points, requesting further analysis, requesting inference, because often students fall down in that. In fact, I do it myself when I'm writing, drafting pieces. I think that the inference from what I'm saying is there, and of course it's in my head, it's not on the paper. And it took me a while to come to this, because how I started working on this, I was a history student. I tried to answer the questions, as did the programmer, and we found we could only get C grades, and we were very, very upset by that, as you can imagine. And so I went to see the history tutor, and I suppose that what I did was a knowledge elicitation exercise, and I found out that really when you're answering history questions, you've got to identify the causality and the variables that contribute to the causality, but you must weight those variables. Once I understood it was the weighting of the variables that gave me the best marks, then I was able to move forward. And in fact, I would like to put onto the system a button that's got rules of the game, because I think this is what the rules of the game are about. And when students say to you, I don't understand something, often it means I don't know. When they're given an assignment, they don't understand it. They don't understand what the task is about. They haven't met a task like this before, and they're not sure how to go about it. And I think the rules of the game should be made explicit. And I also think this ties in with Sadler's work,